This example, we use reference angles once again to find the cotangent of 219. So step one, draw a picture and be careful to go all the way around and to label the reference angle. This is 39 degrees past 180, so the reference angle is 39 degrees. Looking at just the quadrant where it ended up, quadrant 3, both x and y are negative, so the cotangent is the ratio of x over y, so negative over negative. Cotangent is positive in quadrant 3. And then with the calculator, you cannot do cotangent on your calculator, and so you know that cotangent of 39 degrees is 1 over tangent 39 degrees, and so on my calculator I just did 1 over tangent 39, and that was equal to 1.235. And so putting those together, cotangent of 219 is a positive 1.235. Now we're going to use our 30-60-90 or 45-45-90 in a similar way to find the values of all trig functions of 210. So we're going to draw the picture and draw a little triangle. At first, we may not have paid attention to this, but it's very important to remember that we have gone down for the y, so the y value is negative. We have gone left for the x value, so the x value is negative. So we start off over here writing all 6 ratios in generic terms. But then we know that we're looking exactly at 210 degrees, so let's go ahead and take out the generic theta and write in 210 degrees and fill in all of the values. And I am just using the ratios from 30-60-90 that you've already become familiar with, and we have all 6 trig functions. And then we definitely didn't have time for a comic in class today, right? Okay, so I'm just going to skip that. And then this last thing gives a little bit of a different take. Cosine of theta is given as -2/5, but you're pretty sure it doesn't have any special triangles or anything like that, because a ratio of 2 to 5 x to r is not sounding familiar. You're given the second fact that theta is between -90 and +180, and you're asked to find the sine and tangent first and then to find theta. So let's just do one thing at a time and use one piece at a time. So if we were to draw the triangle and put it on an xy axis like I've shown, we have a choice, and I'm going to highlight it with a little bit different color as well. So we know that cosine of theta is x over r, but we know that r is always positive, so the only value that has a chance of being negative is the x. So we assign the x to be negative and the r is always positive. So that's how we got right here, and we've moved left 2, and r is just a distance, so we have decided that that's a good placement for our particular triangle. So we figured out the value of y, so y is the third side of the triangle just by using Pythagorean theorem. And we think we're done, except I needed to rewrite that too because we have another choice. We could have landed in the second quadrant like we talked about with a -2 and a +5 from these two values. Or we could have landed in the third quadrant, and we've still gone left 2 and out 5. The difference between those is that this value of y is positive and this value of y is negative. But the cosine ratio is -2/5 in either quadrant 2 or quadrant 3. So we have two choices. Well, when we're supposed to find sine theta and tangent theta, is it in quadrant 2 or is it in quadrant 3? Well, let's see if this fact that we haven't used yet helps at all. So it definitely helps, because if we look from negative 90 to positive 180, we don't have a choice of having the angle right down here, theta, the real angle, in quadrant 3. So let's go ahead and find sine theta and tangent theta using the values of x, y, and r above, and being careful with whether they're negative or not. Okay, and so there are those two values. And let's take the inverse sine of our answer. Okay, and we know that our value of theta is in the second quadrant. And so when we take the inverse sine, and I'm working right here right now, when we take the inverse sine, we get 66.4 degrees. Well, this angle of theta is not 66.4 degrees. We know that it's obtuse, so we know that it has given us the reference angle. How do we figure that out? Well, we know that this reference angle right there is 66.4, so we subtract 66.4 from 180, and we get our value of theta. And that's all for this screencast.